I see. All right, see how to do this. I see. Right, so it has to be like right, so literally trolling. Of length K. I see. Oh. I see. Okay. Okay. Mm-hmm. Okay. I know how to do this. I'm getting a call. Hello? Hello?
Hola, buenos días.
Okay, it was a spam call. Anyway, so now it's just like probably silence that. No, do the same thing backwards, right? Right. So now we just need to sum the number of right? We just case on the so this is the case where we don't make any changes, and then we how do we do this? So this will be like a split. This will be like a join, right? I believe, right? Yeah, okay. Actually, would you ever want to turn an odd thing even? You wouldn't, right? So you'd only want to do it ever want to make odd things even. To make an odd thing even, it's just like it's a join operation, right? It's like all right, now it's just gonna be like this is a split, right? But maybe I have it mixed up. You only ever want to make bad go down, right? So you'd want to split. Am I confusing myself? Okay. All right, I think this seems correct. That's very sus. Let me try something else. This will be like that's obvious, and now it's like yeah. Finally, something like I think it should be 9. Okay, whatever. Okay, cool. Wow, okay. Speed is difficult here. It's okay. Speed on early problems doesn't matter. Given an array A of length n, both of these are prime numbers. This is interesting. This means that at least one of them has to be 1. And the other one has to be prime, right? So just 1 and 2, right? Isn't that literally the only... Updated most. So now it's just like, here we want to take the subarray. And I think ideally what we'd want to do is find the number of 1s and 2s and then just add until they become equal, right? Okay, it's easy. What are the queries like? Okay, now let's make 2 prefix sums. Alright. Now how do we handle queries? Alright. I think the question here is like, if we have 3, 1, it's better to do 3, 2 or 2, 2. I think it's better to always just do 3, 2. I think ideally you'd always want to deal with the other ones first and only then try to rebalance, right? So I think like the final answer will just be first thing you want to do is change smoothies, right? Without loss of generality. Yep. So now it's just like, you want to make the difference, right? At which point we can't do anything more. So I think this works. 0, 0. Well, first thing we should do is just move this out of the way. Okay, almost. Ooh. My desk has too many things on it. Okay. Interesting. So let's just it's helpful to just look at one query. So 1, 0 here, right? So let's see what it's like after 1, and then what it's like after the second. Um, 1, 0, that's correct. Why is it like this? Let's try that. Oh, this just gets both samples correct, but let's think a bit about it. Alright, so let's just come up with a few test cases here. So it's like, alright, so let's think of something like 2. Let's just say this is like 6, 0, 0, 0, 0, 0, 0, 1, 1, 6, 6. Should get 9. Okay, let's just submit. Ooh, okay. First try, hey yo. Oh, this is kind of sorry, but it's okay. We're recovering. Who is out here? A lot of people. Chef has a multiset A where each element is in the multiset is in that range, right? X becomes 2x or x becomes 2x plus 1. You want the mex to become this. Okay. Meaning that you want to cover everything below but not touch this, right? Interesting. So I think for one, if there's a 0 in there, keep the 0. If there's a 1, I guess it's interesting to know, like, what's the shortest path to anything, right? Or, okay. So it's mex queries too, right? So what's the query like? For each, I see. Okay, let's just think about 1, 0, 1, right? We want to make the mex 0. Just one operation, we just go to the 0. We want to make it 1. 2 operations, right? 3, 2, 0 operations, 3. What do you have to do? 2x or 2x plus 1, right? 1 operation, 4. I think I'm getting ahead of myself. Yeah, 4 is impossible, right? So 1, 2, 0, 1. Wait, you can. Oh, if you want to make the mex 1. Oh, yeah. Wait. How is the answer not 2? What? A little confused. Oh, they give you frequencies. They don't even. Okay, that's really weird. Okay, so it's actually 0, 2, right? Okay. So that's interesting actually, because this means that these numbers can be really big. So, it's like if we want to make the max a given value, right? What you have to do is like you have to find the cheapest way to get something here, right? I guess one thing is there only one way to get an element? If it's odd, you have to do this. So really, you can always determine where you should have started with, I believe. And furthermore, I don't think it really matters. Actually, on a given path, is it better to have this, or this? I think it's the same thing, so it doesn't even really matter. But this operation is quite deterministic, right? Because if you want to make 2, 2 had to have come from 1, which has to have come from 0, right? So we can just like kind of get that path. And then just like... And this path is like logarithmically big too, so... And then it's just like... If there's already stuff here, we just have to like erase all of it, right? Okay, sure, I know how to do this. Let's just... Now I want to find the minimum cost to handle this, right? So now if f sub I, you have to take it, right? Meaning I don't have this feature. Okay. Alright, so now I just have to like keep like moving the thing down, right? So alright, so val mod 2 equals 1. Actually, just generally val divide equals 2, right? F(i) is greater than 1. And would be Oh, how? How does that happen? Oh, do I just have to do that? How big is this array gonna be? Okay. Oh, okay. That just worked. Oh, beautiful. Oh, nice one. Let's look at ranks right now. Expected sum. Oh, I'm so excited. I love these problems. First element randomly from any of the arrays, and then from second element onwards, equal probably choose an element which is strictly greater or belongs to an array. It has to be both. So it has to be another array and strictly greater. So I see. So it's like a random walk type thing. So you can guarantee that the sum is like different, right? So it's just like a graph of, you just have a graph, and in each step you just pick something reachable, and then expected sum. Okay, cool. You just want to find the probability that each number is in your sequence, right? So when would that happen? It's like, oh, does it say what you start with? Okay, you just randomly start from any front, right? And then it's just like, what has to happen is that, I guess it's just the sum of the probabilities that I get to any of the things that can reach me times the, I guess, 1 over the number of things each of them can reach, right? So you just have to do like a multi-pointer sum, basically. And its fraction is just fixed, basically. It's weird that the probability is just like monotonically increasing like that, but should be fine. So, alright, so let's implement that idea. Alright. So it's like right, so that does that. Let's just code this part. It's just like prefix sums, right? And I guess the way to handle the start is just to have like a one final thing that has yeah. Because the one thing you need to support is like how many are above me, right? Outside. I think it's useful to make like, okay, so alright, so we should do this. Alright. Just gonna like a down pointer, right? So while I guess ack j dot first less than val down prb is equal to down prb plus prb. All right. Like I said, to store like individual downs also, right? So right? Okay, so now PRB I is probably going to be Yeah. So it's just like the difference of them, right? And then finally PRBI. Int num above equals, let's just create num above, right? Inv, how did I define inv? Should be how do I count num above? I think there has to be like a separate pass for this. Yeah, let's just like separately compute that. And the way they should be computed is just like alright, so int register. Alright. So if I is greater and I guess ac I dot yeah, so it's just like that means right now we want to just do yeah, at this point it's just like num above I is equal to reg minus indreg ri dot second ac j dot second. Okay, this hopefully makes sense. So this is just the number of numbers I could possibly land at next. Alright, and then given that, this is just like the probability that a given element is touched is just you case on what the previous thing was. I think this is actually the proper way to do it. Or actually, no. This is the way to do it. If I we shouldn't do any of this for one, right? I don't think so. X, this is actually inv, right? Because it's like, alright. 60. What was the issue? Oh. Oh, you never declared ends, I don't think? I did not. Okay. Okay, so it gets the first symbol correct. Doesn't get the second one. What would the expected sum here be? Why is it 3? Oh, that's true. Oh, that's actually quite annoying. It should start from the front, and it's not sorted. How do you deal with that? I guess it's just like, first of all, don't bother with the 0 thing, and second of all, like, just preset those probability values. Right? Like, what else can you do? And even those can just be like modified, right? So yeah, I think the way to fix this is just to like yeah, so you just modify it in place like that. And you might already know a few of them. Num above can stay the same, I believe. The only difference is that you no longer do this. Yeah. Alright, let's see if this works. That second, okay. Okay, I think we just need to do tuple access. It's kind of annoying, but yeah. Okay. Okay, please. Okay, it's getting an answer. Let's think about why that is. Okay, so let's see how it's, what's it called? All right, why is this? So in this case, 5 has that probability, really? Why would it have that probability? Are we even sorting it? Why is... Oh, we're starting here. Okay, 1 has 0 probability. 3 has 1 probability. Where is 5's probability coming from? Because it should be subtracting things, right? Like, these two things should be the same, right? So let's, I'll put these two extra things. So let's see what Dion, Pierre, and, right, because we should be... These are both 0, 1, and 2. Interesting. When did we ever add to this, right? Oh, that's the issue. Silly bug. Oh, so it's not getting a few of the bigger cases correct. Let's just see what the answer is, I guess. Ooh, it doesn't get either of these correct. This is case 2, right? Let's think about this. I'm a little stressed, but also I think if I get this problem, I'm home free. So let's just focus. So it randomly gets to one of these like fronts, right? So distracting. So now if I go here, then I can hit either of these, right? So the probability of hitting 4, 3 is just, I guess it's half plus half times yeah, this is just half, right? Probability of hitting a 4 is just going to be, you have to hit this, then you have to. It should be, you have to start here and then you have to start here, so it's still half times the third. Alright, so that gives us some context here. Oh wait, PRB I is equal to null PRB I didn't even do that yet. Magically it gets that correct, but now I hate it when I have to debug these one by one, because that means it's such a high probability I get a wah. Nothing to do about it. So again, it gets 12, 3, 5008 correct. Just gets this case wrong. Okay, so let's think about that. How about we just look at what num above is? Because that is a very easy thing to debug. So the 1 here can reach 1, 2, 3, 4, 5. Yes? The 6 here can reach 1, 2, 3, 4, 5, 6. Wait, what? 1, 2, 3, 4, 5. Okay, that's correct. The 7 can reach 1, 2, 3, 4. The 8 can reach 1, 2, 3, 4. The 10 can reach 1, 2, 3. Actually, no. 1, 2, 3, 4. 12 can reach 1. The other 12 can reach 1. Actually, these 12 should not have the same reach because... Oh, but they can reach each other's 100. Okay. The 200s can each just reach 0. Okay. I see. Alright, that part seems correct. I guess I just have to debug now. So let's look at this thing right here. So prob of hitting 1. This is just 1/3. Two, get rid of these numbers. Alright, so next thing is 6. 6 just has to be oh my god, this is so hellish to debug. This is so bad. Surely I'm just like missing a mod somewhere or something. It has to be something simple like that. Do I have the correct mod? I do have the correct mod, right? 29 plus 7? Yes. Is my inverse formula correct? Yeah, it is. Okay, just do the sample. Just do the sample. Stop being sad. All right, so this is gonna be like, you have to start from here, and then you have to have a. How many things can it reach again? 1, 2, 3, 4, 5. Right. So times. I don't know what 1/15 is. Let's see if that is correct. Well, the probability of hitting 6 is what actually. Okay, 1/15 is correct. So let's try next 7. This is this. For this one, it's just 0, right? Because you have to start with. I guess it's 1/15 times however many things it can reach. So 1, 2, 3, 4, 5. That seems correct. Is it possible something is factored in before we know things about it? No, that can't be true, right? Because this has to be less. So like we're like live computing it basically. So okay, whatever. 7, right? So now we got, let's get a 8. 8 has to be like, once again, either 1 to 8 or 1, 6, 7, 8. So it's either one, 2, 300 equals 21 over 300 equals I don't want to keep doing this. I think, yeah, no. I don't think there's any point in doing this by hand more. God, what could be wrong with this? Because they don't explain the last sample at all, so. Let's just spot check a few other things. Does everything have non-zero probability? Everything does. Let me just spot check again for mods everywhere. This is fine, this is fine. This is fine. Yeah, I don't do mod addition that much. Let's try hash define. And then let's do. Does that fix it? No, doesn't fix it. Or actually, does it get a different answer? No, it doesn't. I guess one thing that's not clear is when you end. But no, that should be fine. Is it possible that they updated the sample? They did not. Is it a index thing? Okay, let's think a little bit about my method here. Or let's try to come up with a simple case, actually. Let's try, what does this get? Should get 5. Oh, interesting. Why doesn't it get 6? It should get 6, right? Oh, I guess you're always gonna end up at 11, so it's, damn, okay, I see. Oh, I guess one thing here is that, well, j is less than. Could just be an out of bounds thing. No, that's not it. What the fuck? Wait, I just can't compute the sample by hand. Maybe this method is wrong? Alright, so just like 11, 17. Oh, because yeah. It's either 22 or 12, so 17. Let's read the problem again. Strictly as increasing sequence, randomly. Randomly from any of the arrays? Oh my god. Oh god. That's what it... I just misread the problem. God damn it. And somehow passed most of the test cases. What the fuck? That's so sad. Okay. No, that's so sad. Okay. I think it's going to be really sketchy whether or not I make it. Okay, at least like a lot of people seem to be getting problem 6, so maybe it is doable. We'll see. You're given two arrays A and B, each consisting of n positive integers and a positive integer k. For positive integer x, we say a set of indices to be x good if their bitwise OR is at most x. Oh, beautiful, another combo problem. I'm so happy. Right, so it's just, yeah. Is this Walsh-Hadamard transform or convolution? But it's not product, it's sum. So it's just like, for each element, find the number of arrays that can contain it, right? How many arrays can contain an element? Or rather, how many ways? It's like you have some submask, and oh, but it's a OR thing, right? So I guess if you have one value, right, you know if it's already bad, and if it's not bad, then it's just like for each bit, you're like, I guess you have some bits that are like, if you turn it off, then you can just do whatever you want with the rest of the bits, or if it's on, you have to think about it, right? So you can just do some kind of tracker like that. So case on like the first time at which you allow freedom, and then it's just like, okay, you need an array that has ones until this point, and everything else can just be whatever, right? So it's just like the number of arrays that have at least one up to this point. So it just can't be. But it's interesting. How many ways can you pick a set of elements? I guess we are overcounting, so it's like case on the first like 0, right? Which means that nothing can have this bit. But every like higher bit needs to be like, it has to be at least 1. Oh, it looks like principal inclusion exclusion type thing. How big are the numbers? Ten to the 6. Oh no, you have to do PIE, I think. I'll walk around for a bit. I guess for or it's easy to constrain something that it can't have rather than something that it can, right? Because then it's just like, yeah. So, how many ways are there to fix something that has an or that is a submask of this? And once you have all these like or at most queries, you can like do some, you know, combination to get like the exacts. Less than or equal to x is such an annoying condition. Let me read the problem again and make sure that's what they actually want. Oh. Interesting. So you actually want this answer for all k. I see. Okay. I guess we could just do TP but with like non-sum, right? Oh, I see. I see what we can do. Okay, yeah, this is just like subset DP again. But we have to be a little bit careful. So what we can just do is like store how many ways to get an OR of exactly x, and then prefix sum that. I don't entirely get the point of the prefix sum, but whatever. So now it's just like SOS DP, right? So I guess each mask has like the number of ways you can pick something, and also the sum, right? Okay, let's formalize this. It's not actually obvious to me how to do that though. Let me look at like past contests that I did and see if the problem is similar. This one. Oh, that's actually true. Or submask X just means everything is a submask of X, right? So how many things? How many things are a submask of X? Then what we can just do is we can Mobius transform on that to get Mobius transform on that to get submask exactly X, then prefix sum that. Okay. That's actually fine. And then it's like, you want sums, right? You don't just want num. I guess it's like, you want to count you have a bunch of things, right? And you just want to pick some subset of them. What's the sum over also? Oh, that's actually really easy math. That's really easy math. It's just the sum times 2 to the n minus 1. Okay. Okay. You got it. I am not losing to another Mobius problem on Codechef, that's for sure. I refuse to. Alright, so now it's just like you want sum, right? So this is the correct mod. You want 49 plus 7, right? Okay. Nice, got it. There's no reason to do it like that, but whatever. Now we just have to zeta transform on it, right? Alright, so now I just have to Mobius transform on this and then prefix sum, I believe. How do we Mobius transform? I think it's just this, but we... Right, so it's just like Okay, and then finally, okay. Oh my goodness. I see. I guess I should not have expected any better. Okay, so the issue here is k equals 3 has a lot more ways to do it, so than it looks like, so. Subsets that XOR 2, that OR to 3. That is wrong. It should be 1. It's still 1. 1, 3, 27. Not good. Number of subsets that OR to 3. I see. Let's once again look at how I coded this. Oh, same issue. 1, 3, 24. How many submasks XOR to 20? It's like just 3, 3, 2, 3, 1, 1, 2, and then 1, 2, 3. It is 5. So it's the sum computation that's wrong. But I think more interestingly, why is this getting 0? So let's look at 1 here. Oh boy, I would love to get this problem. Would really love to get this problem. Because then I'm definitely probably good. Okay, so number of ways to pick a thing that XORs to 1. Interesting. Interesting. Oh, wait a minute. Oh, I don't even... Oh, that's why. I see. Oh, look at that. It's correct. Okay, let's see. 1, 3, 20, 6, 6. Let's pray. Damn. It's a punch to the gut. Okay, what could be going wrong? Okay, let's just do like a funny example here. So this is gonna be like, let's just say like 7, right? 5, 7, 7, 7, 7, 7, 7, and then it's just gonna be like 1, 2, 3, 4, 5, right? What does this get? So it should be like 15 times 16, 240. Yeah, that's correct. Interesting. Why did it get 15? I see. Okay, cool. I broke it. Let's see why it got that. Ah, okay. Let's go. Ah, thank you. Okay, measly 13th place. I don't really care. That's a pretty good performance. Where am I here? Oh, this hasn't even like updated. I think in around 2 minutes it'll tell me what my actual rank is. So cool. Okay, let's look at the last problem just for. We're given an array A of size n. There is a complete weighted graph with n nodes and this many undirected weighted edges. The weight of an edge between I and j is the max of this subarray. Interesting. Okay, 30 seconds, let's see what my actual standing is. All right, update please. Okay, still not updated. Okay, rank 11 is pretty good, but how many 6 stars are passing me, I guess, is the interesting question. Not too many, I don't think. I only see 1, 2, 3, 4. Oh. Wow, my rating is so on the line. I think if anyone solves max path here, then might not be too good for me. But I don't know, this thing has been inaccurate before. I think 11th place deserves a bit more than like 10 rating, so okay. Anyway, let's see if we can solve this. You're given an array A of size n, there's a complete weighted graph, right? Okay, so, and it's given by an array. Find the shortest path from 1 to n. So, is there a reason you can't Dijkstra? It's because range mex is difficult, probably. I see. How do you even compute range mex? I guess it's like from a fixed like starting node, from a fixed like starting index. The mex will get bigger as you increase the right endpoint. Let's think. I guess like you can fix a mex, and then like find the set of subarrays that have that. No, doesn't really help. I think intuitively, like, you want to take small edges, right? You want to keep taking very small edges. Like, wouldn't you just want to go 0 to 1? If it's a 0, if there's no zeros there, you win. Because, like, you have to eventually, like, touch everything, right? So, yeah, why wouldn't you just, like, go 1 by 1? Like, in this case, you want to go here, right? So, 2. Oh, this adds 1, this adds 0. I see. So for ranges that don't have a 0, you want to just, you can zip past them, basically. So yeah, wouldn't it just be, like, number of zeros then? Or I guess not precisely, because you can't ever avoid the beginning. So if like 0, 1 exists, then you just can't avoid it, I don't think. So 0, 1, you have to swallow the 2, and then actually 1, 3 just works. Does it have more solves yet? Except 3. Is McKenna someone that's already ahead of me? Okay, McKenna's already ahead of me, so it's fine. Just check like US rankings pretty quick. Okay, so like no one's doing this. Okay, this problem. This feels like a DP, kind of. Because I think a very clear observation is that you want to go through nodes in increasing order of label. So in this case, what do? You start here, and somehow the answer is 3. So if you just go here, you only have to pay 1. Now you have to pay 0, which is good. And now you have to pay 2. And that's how you get 3. I think, like, if you have the... It's always optimal to go all the way until the next 0. I believe. So then it's just Dijkstra, but like on zeros and stuff before zeros. And then these edges are quite easy to compute the max for. So does that just work? I guess for each node, just like store. But I guess for each node, just like for each possible max, just like you have a range of nodes that give you that max, right? So then it's just like range query. So it's just like segtree or sparse table or something. Segtree, it's just segtree. Is it possible to get those like limiters for each max? Can you do that quickly? Don't think it's obvious to me you can. Oh wow. Accuracy is really low, so maybe this is just a troll problem. I don't know. Let's see how many people actually submitted to anything in this contest. Well, it's at least 162. It's a fair amount. Yeah, the frustrating part of this, like, thing about this part of the contest is it's too late for me to, like,
even if I solve this, I can't implement it in 5 minutes. So I just have to sit and like hope no one else solves it, basically. And then just like look at the predictor at the end. Getting those demarcations for the mechs, I think even that's not enough because there might be like, you know, a lot of mexes, right? So it's not obvious to me like you could make some observation that your mechs should never be above like 5. I think this makes a lot of sense to me. So it's just like, oh, you just have to store like find like the first one, the first two, the last 0, the last 1, the last 2, the last 3, the last 4, right? Is that implementable? I can make an attempt. Now we actually want to compute this thing, right? So I guess it makes sense to start something. Actually, you don't really need DP, you just need a seg tree, right? So what would this would just be a max seg tree, right? So yeah, that's fine. So now it's just like, yeah, if A of I is less than 5, right? Now it's like, okay, seg tree. At the end, you just want to I just want the range for each max, right? So how do we get that? I think you actually want a min seg tree, so this will be like 29 min. Well, let's just do money. I don't know what I'm doing. I can't finish this in 30 minutes, in 30 seconds, but query equals min cur c dot query lr plus val. I just how to populate ranges, and then that is the problem. So with a sketchy observation, I guess. But anyway, contest is over. Let's take a look at the final thing. Oh my god, I'm so on the line. I think like, I don't know, I think that this thing is like pretty accurate. If anything, it's pessimistic. So I think I hit red on Codechef, albeit barely. So that feels good, hopefully. Okay, I guess we'll just go over solutions. For this problem, I guess the claim is that in order for you to be able to build everything from 0 to 1 to 2 to the k minus 1, you just need like a 1 0 0, a 0 1 0, and a 0 0 1. So like here, like 0 1 and 1 0 are both present, so it works. Here, 0 0 1, 0 1 0, and 1 0 0 are all present, so it works. So you just need every possible string with exactly 1 1 to be present. And then it's yes. For this problem, it states that you want to flip the parity of exactly one element and then maximize the number of subarrays that have at least one even number. So I guess the observation is that this is equivalent to minimizing the number of arrays that have all odd numbers. And that's a much easier thing to count. So yeah, you can basically just do some like basic combinatorics and then case on which index you flip. And I guess the observation is that you only ever want to make odd things even, like just intuitively. So it just turns into a problem of like you have two ranges, merge them, and then recompute the number of bad subarrays. Yeah, that's kind of it. So this problem is funny. Basically, the key observation is that this is true if and only if AI and AJ are 1 and 2, or 2 and 1. So really, it's just asking you, given a subarray, you can make k modifications, maximize the value of the number of 1s times the number of 2s. So after that, it's just like a bunch of like, different stages, right? So I guess stage 1, use the remaining elements to make the number of 1s and 2s even. Stage 2, use the remaining to increase both number of 1s and 2s. Stage 3, no remaining elements left. Try to rebalance the number of 1s and 2s. And I guess like the key reason why you want the 1s and 2s to be balanced, given that the total is constant, is just that like if you have x and y such that x plus y equals k, xy is maximized when x equals y equals k over 2. That's just like, AMGM, I guess. So that's basically what it's doing. Like this is just modeling each of these stages and sort of greedily, and then you get this answer. For this problem, the key observation is that this operation set is unique. Or rather, if you have a final number, you can uniquely determine what has to have been the previous number. So from that, I guess what you do is you just go through each number and then greedily try to see if you can pick out a number whose frequency you have extra of, and then just take the first one you come across, I guess. Yeah. For this problem, it's just kind of like a prefix sum computation. So the idea is that I guess you want to use a linearity of expectation. So you want to find some all elements of probability EI appears times E sub I, right? And probability EI appears equals some elements in other arrays that are smaller of probability E sub j appears times 1 over we get e sub I after e sub j. And that latter probability is just 1 over number of elements above e sub j that is also in another array. And this quantity can just be pre-computed, and then you can sort of compute this using a bunch of prefix sums. So yeah, that's basically it. And for this problem, it's just, this is basically it. We want to count the number of ways to get, so basically you can reduce this problem to get the number of the total goodness among, you can redefine x good to be the equality case and then just take the prefix sum for the inequality case, right? So now let's just assume this is an equal sign. So what we can actually do is, if we want to find the number, the sum of these b values among everything that has an or of x, we can actually relax it to among all arrays that have an or that is a submask of x. And that's actually an easier thing to compute using SOSDP. And then you sort of invert the submask condition using Mobius transform or inverse SOS. And then, yeah. Sorry, I'm tired, so I'm not explaining this well. But yeah, that's basically it. It's just SOSDP and Mobius transform. And yeah, that's the contest. I had a sketch for this, but I have no faith it is correct, so I'm not going to go over it. Oh, okay, cool. So I am definitely hitting red today, so okay, that feels good. Anyway, yeah, signing off.